Hey guys, hope you're all doing great. Welcome to this video tutorial on assembly modeling using SolidWorks. And in this video tutorial, we are going to take a look at one interesting assembly, which is a two-jaw gear puller. Okay, so on to my left, I've got the drawing. So this is going to be the gear puller that we're going to model and then assemble using SolidWorks. And as you can see from the drawing, it has got 7 parts. Okay, so the first part is going to be this yoke, which is going to be what we're going to model now. And let us get started. Okay, so let me just zoom in a bit so that you can see the geometry a little better. Yeah, alright, so to start with, we're going to model this yoke. Okay, fine. So let us start by creating making sure that the units are in mmgs. Okay, and let us start by creating a sketch on the top plane. Okay, so we'll just sketch this rectangular profile and extrude it to a depth of 18 mm, and this is a very simple component to model. So we'll switch on to the top plane and let us use center rectangle, and with the origin as the center, just draw a rectangle like this, and the length is going to be let us draw the inner part first, and then we can draw the two upper rectangles. So this length here, as you can see, this is what is going to be the length, and that will be we'll just calculate what it is going to be. So first of all, the width is straightforward, so it is 6 mm. I'm just going to add dimension here, and let us say it is 6 millimeters. Okay, and now to calculate this length, if you can see from here to here it is 20, same way from here to here it should also be 20, and this entire length is 58. So there's going to be 58 minus 40, which is going to be 18 mm. Alright, so this will be 18 mm. Okay, so this looks pretty cool. So the upper, so the center rectangle is drawn, and now let us draw the upper rectangle here. Okay, so what I'm going to do is I'm just going to resize my screen. Yeah, this looks cool. And what I'm going to do is I'm going to draw a rectangle like this. Okay, on top, like this. Yes. Now this length is going to be 58 mm. I'm going to call this, or what we can do is like we can find the center point. I'll just throw this up. Let us try to find the center point. Yeah, this center point and origin, you can say they are going to be coincident. No, sorry, you can call them as vertical. Yeah, and then you can add a dimension to this, and this is going to be 58. Okay, alright, so use zoom to fit option. So this is 58 mm, and then as you can see, the thickness is going to be 6 mm. So I'll add dimension to this part as well, so I'm going to call it as 6, and then select this line and this line and say collinear. Yeah, perfect. So this looks pretty good. And now what we're going to do is we are just going to mirror this. Okay, so to mirror, you need to have a center line. So let me just draw the center line like this, which is going to be passing through the origin. So it's nothing but a horizontal which is passing through the origin. And now what I'm going to do is I'll go to mirror entities, and entities to mirror are going to be 1, 2, 3, and then this fourth line. Okay, these 4 edges, and I want to mirror it about this line. Yeah, so mirror about is going to be the horizontal axis. Fair enough. Now you've got the entire profile, and now we just need to trim the unwanted edges. So let us just trim all the inner edges, and if I am going to fit this to my screen, yeah, so now we can just extrude it. So I'll go to features, extrude, and let us use the midplane option, and the depth is going to be how much? 18 mm. Okay, so let's put in 18 here and say tick. Okay, so this component is almost ready. So as a last part, we have to drill these 2 holes and also this hole here. Okay, so let's start by drilling this hole here. So it's going to be a M12 and it's going to have a chamfer of 1.75. So select this plane and say sketch and say normal to, and with origin as the center, draw a circle for 12 mm. Yeah, going to be 12, and extrude cut it to a depth of blind, like through all, I'm sorry. So it just needs to run through the entire length of the model, and you extrude cut it. And now we can use the chamfer option, and it's going to be 1.75 because it's given as M12 1.75 here, and select this one here. Fair enough. So this is the center hole through which basically this component is going to run across. So this component number 3, which is the screw, that is what is going to run across this hole here. Okay, and now let us drill these two little eyelets here. So select this face and say sketch, and then normal to, and then so the center of the circle should coincide with the horizontal, okay, which is going to pass through the origin. Yeah, and the dimension is like 8 mm, so 8 mm 2 holes, that's what is given here. So I'm going to say it is 8 mm, and the distance from the center is 19 millimeters, as you can see here. So this distance, I'm going to say it is 19 mm. Okay, and then let me just draw a vertical line and then mirror this as well. So I'm just going to draw a vertical like this. Okay, this, make sure that it is a construction line, and now you can go to mirror entities, and entities to mirror is going to be this arc, and mirror about is going to be this line. Fair enough. Now you can go to features, extrude cut, and then cut it across. There you go. So this is how our yoke is going to look like, and if you wish you can give some color to it. So go to appearance, and then go to open appearance library. You'll have a library that's opening up here. So select, go to color, and you can select here, double click this so that the geometry selection opens up. This is going to be for the entire part. So let us say that this part is going to be something in this color. Okay, fair enough. So now our first part is ready, so we have to save this. So I'm going to file, save as, and create a new folder, which is actually a good practice. It's always nice to have all the parts in one folder so that it will be easy while we assemble it. So I'm going to call this as gear puller. Okay, and to call this as part 1 underscore yoke. Fair enough. So this is how we create the first part. Now let us proceed by to model the second part, okay, which is going to be this one here. This is going to be slightly complex. So this arm is going to be slightly complex when compared to all the other 7 models, which are going to be fairly easy, but this guy alone is going to take a little bit of our time. So let us start it now. I'm going to go to file, new part. Yeah, by default, for some reason my SolidWorks is going to have the default as a inches IPS, inches pound second. So I'm going to change it to mmgs. And now let us start by creating a sketch on the front plane. So a gentle reminder, we are going to model this arm now. So till now we have seen how to model the yoke, and now we're going to see how to model this arm here. Okay, so the complexity with this part is that it's fairly simple, but the only thing is that one part of this profile is having a thickness of 5 mm, while the bottom part is actually having a thickness of close to 12 mm that you can see here. Okay, so this 12 mm and 5 mm, these two are going to this one single component is going to have 2 thicknesses. Okay, so let us see how to model that now. Let us start by creating a sketch on the front plane. So select front plane and then sketch. Fair enough. Now let us draw the outer bigger circle. Okay, this circle which is having a diameter of 20 mm. So with origin as the center, let me see, this is going to have a diameter of 20 mm. Fair enough. Now let us draw this arc here, which is having a radius of 6 mm. So this is going to have a radius of 6 mm. So this is going to be 12 mm. Alright, and the distance between the two centers is going to be 23 mm. So the reason why it is 23 is because the total distance is 29 and already 6 mm is gone here, which is the radius. So from this point to this point is 29 minus 6, which is 23. Alright, so this looks pretty cool, and the reason why it's not fully defined is like because I have to say this as vertical, sorry. Yeah, and now let us draw two lines here which will be tangent to both these circles. Okay, so I'll draw a line like this, select these two circles and say they are tangent, select this line and this circle and again say it is tangent. So this way this line is tangent to both these circles, the small and the big one. Similarly, let's do it for this side as well. Okay, this looks cool. I'll select this circle, this line and say tangent, add a relation, and this by default should also be tangent. Yeah, I can see this tangent here, but anyways I can give it, no problem. Okay, so this is how we can sketch this little part here. And now if you can see, we are having line which is 22 mm long, which is starting from the center. Okay, so what I will do is I'll take a center line and with origin I'll draw a line here. Okay, and then again from here I'm going to draw a solid line. So this is going to be 22 mm. Let me add a dimension to it and call it 22. Alright, so now what we have to do is like we have to draw a horizontal which extends up to the center line. So I'll draw a horizontal like this. Okay, yeah, this looks good. And now we have to draw this curved profile. Actually this length has not been specified, so we can have it like anything. So to have a decent value, let me just place it here somewhere and let's add dimension. Okay, 4.7, fine, anything is okay. And now what we have to do is like we have to draw this 10 mm radius fillet here, right? So let me just draw a line from here to this circle which is going to be a tangent to the circle. So select the circle and this line and say tangent. Okay, so now this is a tangent, and now you can go to fillet and 10 mm, yeah, select this edge here. Perfect. So now you are having this R10, right, radius 10 that you can see here, and this is what is being shown here in this fillet radius. Okay, alright, so this looks pretty cool. And now what we can do is we can trim all the unwanted lines that you can see here, and let us draw this center circle also, which is going to have a diameter of 8 mm like this. Yeah, and it's going to have a diameter of 8 mm. You can either cut extrude this later on or just have a profile like this and use a single boss extrude command. So in extruded boss base, this is going to be 5 mm, and now we are going to use the midplane option. Cool. So now what we have done is like we have just sketched up to this point. Okay, this part has been sketched and made, which is going to have a thickness of 5 mm. Now we are going to model the rest of the components, which is going to have a thickness of 12 mm. Okay, so to do that, what I am going to do is like I am going to create a plane on this face. I select this face and I go to reference and create a plane and say it's going to be here, right? So I'm going to select this face and it's going to be 0 India. So I'm having a plane here. Okay, and I'm also going to create a plane at a distance of 102 minus 29 minus 22. So which is 102 minus 51, which is 51 mm. Okay, so with plane 1 as the reference, I'm going to create another plane. I'm going to plane. So this plane is going to be at a 51 mm distance. Okay, from here. Fair enough. Now on to plane 2, I'm going to create a sketch. Select plane 2 and say sketch. And what you're going to do is select this face here. Okay, this rectangular face. So I can hide plane 1 for a moment. Okay, and just select this face here and say convert entities. select this face here and click convert entities. Now you can see that the impression of that rectangle has been made onto this plane here. Okay, this looks pretty cool, but the thing is, like, at the moment the thickness is going to be 12 mm and not 5 mm, right? So let us see how to do that. So if I go to smart dimension, this one is 5 mm, but basically this has to be 12 mm, right? So I'll go to so 12 minus 5 is 7, right? So on each of this side it has to extend by 3.5. So 3.5 plus 3.5 on both sides is going to be 7 mm. So I'm going to call this as 3.5 mm and also this as 3.5 mm. Okay, so now put together this is 3.5 plus 5 plus 3.5, which is 12 mm. Okay, so now let me just delete this line because we don't want that anymore. I will draw it like this, 10 mm, and then up until this point. Okay, I'm not able to locate that point, so I'll draw like this and then draw it up to this and then convert it, trim it, I'm sorry. There you go, trim. And we should also trim these two lines because it has to be a single line. Alright, so yes, I think we are done. Alright, so now if you can see, we have got a profile here and this one here, and now you can see that this thickness, as it was shown here, this one here is 12 millimeters. I think we are done. So once this is done, you can exit the sketch. And now whenever you have a cross section, whenever you have a profile with two different cross sections, we should be using the lofted boss base command. So go to lofted boss base and select this profile, okay, and this profile here. And now if you can see that there is no preview being generated because these two points are not same. Okay, so if you can see here, this will create a twisted profile. So this green point and this green point should coincide. Okay, so just drag and drop it here. So what you need to do is you just need to drag this handle and place it here. No, not there. It should come here. There you go. So now if you can see, the profile is not twisted, right? So it is fairly straight. This is how it has to be. This is how you use the loft command. So now this profile, if you can see, it is exactly like this one. So this thickness is 5 mm, while at the base it is 12 millimeters. Alright, so now let us try to design this finger here. Okay, this finger is going to be very important because that is what is going to grip the gear puller. Okay, alright, so now here you can see that there is a 3 mm fillet. Let us mark that first. So go to fillet and say 3 millimeters and then select this edge here. Where is it? Here, this edge. The preview is being shown. Click OK. And now 3 mm fillet has been made. Let me hide this plane as well. So plane 2 also I'm going to hide. And now let us try to sketch the rest of the profile. I'll tell you how to do that. Okay. Now select this face and go to sketch. Yeah. And now, so let me just zoom in a bit here at this point. Okay, so now with the place where this fillet is ending, like at this edge, let me just draw a line like this. Okay, this way, and this distance is going to be how much? Yeah, okay, we have got an angle here that's going to be 18 mm. So go to 18 degrees. Sorry, I'll go to this and this and call this as 18 degrees. Yes, and I'm going to select this line and okay, what we can next do is, like, with this as the center line, draw a construction line of length 1.5 mm. Okay, so 1.5 mm. Okay, now draw a circle with this point as the center and the radius as 1.5 mm. Just draw a circle. Now what you need to do is select this circle and select this edge here and say tangent. Okay, There you go. So you've drawn a circle which is going to be tangent to this edge here. Alright, this looks pretty cool. And now you need to draw a line from here. Okay. Oh no. So here you are arriving an arc of 2 mm radius. So we'll go to 3-point arc. Okay. And select this edge. Place it somewhere here. Just draw it like this. And add dimension to it. So this is going to have a radius of 2 millimeters. Okay. Now select this circle and this arc and say tangent. Yes, so now it is a perfect tangent. And now we have got this endpoint. Okay. So we just need to close this sketch. Where this arc is ending, from there to here, you need to draw a line. Yeah. And now what you have to do is like from this point here to this circle here. Okay. Draw another line. Okay. So why we are doing this is to cut the unnecessary part, like we just need to cut this profile so that you have a angle line here. Okay. And then do the same for this one also. This is protruding, so let us trim it. And just zooming it again. And then with this as the center, just draw it like this. Perfect. So now what we are going to do is we are going to go to you can even trim this one, which is the not necessary. Fair enough. And now you can go to features, extruded cut, and then go to selected contour, select this contour and then this contour here, and then say through all. Okay. So it cuts the entire model. Then say OK. So we are all done. Fair enough. So this is how this profile is going to look like. Okay. This is exactly how this profile looks like in the drawing as well. You can see. Right. So this is how it looks like in the drawing too. Okay. So the what do you call this as the finger or arm? Okay. It's called as the arm, and the arm is ready, and let us change the appearance of this as well. So I'll go to appearance library. Generally in assembly it's not necessary that you should change the appearance, but if you're going to change the appearance, it gives a good look. Okay, it gives a nice complete look to the drawing, and it will be easy for us to differentiate each component better. So let me make it golden colored. Perfect. Alright, so I'm going to save it as part 2 arm. Part 2 arm. Okay. So the rest of the components are going to be pretty easy to model, not as complicated and strict as this arm was. So let us proceed. Okay. So now we are going to model the third part. I think it's going to be this one here. Yeah. The third part is going to be the screw, and for the screw we need to have a cosmetic thread as the image shows. The one that you see here is the cosmetic thread. To make sure that the cosmetic thread is visible, you just need to do one small thing. So go to this options here, okay, and then options, go to document properties and go to detailing, and make sure that this shaded cosmetic threads is on. Okay, if it is not on, you'll not be able to see this thread. Okay, it will be created but it will not be shown to you. In order to avoid that, and we'll be worried like it is not being created, to avoid that we have to turn it on. Fair enough. So now let us start by creating a sketch on the front plane. Okay, so here is the front plane, and draw a rectangle like this. We are going to use the revolve command. Okay, now select the origin and this line here by pressing and holding the control key together, and select midpoint. So what we have basically said is that the origin is going to be the midpoint of this line, and as you can see, the length is going to be how much? 116 is it? No. So it's going to be 116 minus 6 minus 6. Okay, so it's going to be 116 minus 12, which is 104 basically. So this line is going to be 104 mm, and as you can see, it is going to be a M12 screw. So half of it will be M6 because you're going to use the revolve commands 6. I'm sorry. So on the other side there will be another 6. Okay, so now you can go to revolved boss base, and you can use this edge here. Alright, perfect. So this looks pretty cool, and now let us try to add the cosmetic thread. Okay, so to add the cosmetic thread, you need to go to insert, annotations, and then go to cosmetic thread. I'll do it again. There's some error. Annotations and cosmetic thread. Yeah, and then thread settings. You just need to select which edge it needs to start from. Let it start from this edge, and then it has to be blind. Okay, and then you have to specify the depth. So the depth is going to be 116 minus 22 minus 12. Okay, so this is going to be is it this one here? Yeah, 116 minus 22 minus 12. I think it's 82. Yeah, there you go. Perfect. So this looks pretty cool. So this is the cosmetic thread that has been shown here, and then we need to draw a conical point here, and this conical point is going to have an angle of 60 degrees. And yeah, so to get a better understanding of how this is going to look like, let us see this entire assembly. So here it needs to be a rectangle, and then we're going to have a conical tip. Okay. Okay. So to do that, let us go back to the front plane, create a sketch. There you go. For some reason this thickness has not been specified, so we can just assume it. I'm going to draw a line of 6 millimeters here. Okay, this is going to be 6 mm. Let me just zoom in a bit here. Yeah, this is going to be 6, as you can see here, and then I'm going to draw another line here. It's going to be from here. Yeah, and let us say that this is going to be 5.5. Yeah, 5.5. Okay, now what I'm going to do is I'm going to draw another line. This is going to be another 6 mm from here. So it's going to be the conical tip. I call it 6 mm, and I'm going to add an angle to it. Okay, so this angle is going to be, and then it will come here, and let me just add an angle to it. So this angle is going to be 30 degrees. Okay, so 30 and 30 on the other side is going to be 60 degrees, and now we can revolve boss base this about this axis. There you go. So now we have got the complete thing of the what do you call this, as the screw. The only thing that we need to do is to drill this 8 mm hole, and that's because this long handle that you can see here is going to go through that. Yeah, fair enough. To do that, you can create a sketch on the right plane. So select right plane and go to sketch. Okay, and select and say normal to. Now what you have to do is like draw a circle here and say this is going to have a diameter of 8 mm, and from the top it is 9 millimeters. Okay, so to position the circle from here to here, it's going to be 9 millimeters. Perfect. And now use the extruded cut command and say through all both sides, then say OK. So now you can see that the center hole has also been created, the 8 mm hole. Everything looks fine, and now you can see that the material that is being used here is 1020 steel. Okay, so in different parts, every part here has a material name 1020 steel. Let me quickly tell you how to change the material. So you can go to material here. If you double click, it will open up, or you can right click and say edit material. Sometimes right click and say edit material, and now here you can see 1020 steel. Okay, so under steel 1020 is available. Select that and say apply and say close. Now you can see that the color has changed and this is how you can change the material property. Now you can see it is IC1080. Perfect. So now our screw is also ready, so we can save it as part 3 screw, part 3 underscore screw. Fair enough. And so I think now you know how to change the material property, so you can change that for every component here. Let us see what is the fourth component. I think the fourth component is the spread nut. Yeah, spread nut also needs to have the revolve command. Okay, let us see how to do that. Part 4. I'm going to make part 4 now, and yes. Okay, so let us start by creating a sketch on the front plane. Okay, let me draw a line like this and say that the origin is going to be the center point, midpoint, then say okay. And now if you can see, the entire depth is 13 mm, so I'm going to say that this is going to be 13 mm. Yeah. Okay, and now as you can see, this is 32 mm, right? So the outer bigger circle is 32 mm. So let us try to quickly see what this is going to look like. Okay, yeah, so this is the spread nut that you can see here. This is the spread nut, and so here it is 32 mm, and here bottom it is 22 mm or something. So you have got two different sections here. I think it is 22 mm. Yeah. So let us draw the upper section first. So the upper line is going to be 16 mm. Okay, mark dimension and say 16, which is half of 32. Yeah, and the bottom one is going to be 22. Half of that is going to be 11. Perfect. This looks pretty good. And then this thickness here is 13 minus 9, which is 4 mm. So from here, let me draw a line like this and finish it, and add a dimension to this. This is going to be 4 mm. Okay, so I can use the revolve boss base command with this as the axis of rotation, and then I'm there. Perfect. So I need to drill this hole of 12 mm dia. So I'll select this surface here and say sketch, normal 2, and I'll draw a circle of diameter 12 mm and go to cut extrude. Extruded cut. There you go. And it needs a chamfer of 1.75 mm. so that the screw actually sits into it. So I'll go to fillet chamfer and then select this one here and say 1.75. Perfect. So everything looks cool here. We can change the appearance as well. So I'll go to appearances library. I like changing the appearances because it's fun to work around with them. It gives you quite a lot of options, you know, to play around with. So probably I'll select this color, or no, maybe something like this. Yeah, I think this is there. Okay, fine. So we can just save this, save as part 4 underscore spread nut. Okay, fine. Now let us design the next component. It is the fifth component. I think it is here. Yeah, it's the handle. Handle is very easy to model. It's just one extrusion, nothing more than that. So you can go to file, new, part, and what has been given. So if you can see here, the handle diameter is not given, because you should be knowing that from this assembly the handle is going to pass through this hole here, and that hole which is on the screw basically has a diameter of 8 mm. So it indirectly means that the diameter of this handle is also 8 mm. Okay, so go to right plane and create a sketch, and create a sketch circle of 8 mm diameter, 8 millimeters. And now the length can be basically anything. Okay, There's nothing hard. It's given 100 long. Yeah, it's given 100 long. So you can go to extrude boss base and call this as 100 and select midplane. Okay, then say OK. There you go. So this is the handle. This is how the handle is going to look like. Yeah. So there's nothing much here. So if you can see here, this is going to be 100 mm long, but here it is said that there is a M6 screw, okay, which will go into this as well, and it is 6 mm deep. Okay. So it is saying M6 into 1, which is 1 mm chamfer, and it is going to be 6 mm deep. So what we need to do is, like, we have to modify this boss extrude. I haven't seen that properly, my mistake. So it should be 100 minus 6 into 2. Yeah, so it's 100 minus 12. Then say OK. Yeah, and now here we have to create a sketch and draw a circle of 6 mm. Okay, so draw a circle of 6 mm, because this has to go inside the knob. Okay, 6 mm and extrude it to a depth of 6 mm. Extrude it to a depth of 6 mm. Yeah, and the same has to happen on the other side as well. So to do that, we can either use the same way, or you can use the mirror command also. So mirrored face is going to be the front plane, I guess, the right plane. Yeah, right plane, and the features to mirror is going to be this boss base. Then say OK. Fair enough. Now we need to have a 1 mm fillet. So we'll go to not fillet, sorry, chamfer, and say 1 mm chamfer, and select these two edges, 1 and 1. Yeah, this looks cool, and I think we can even add a cosmetic thread here. So go to cosmetic thread and go to document properties, detailing, make sure shaded cosmetic thread is on. Now you can go to insert annotations, cosmetic thread, and thread setting has to be this edge. Yeah, and you can say up to next. There you go, and you can do the same on this, on either side. Yeah, because it was mirrored, so it has made our job a little easy. There you go. So the handle is ready. So I'm going to save as handle part 5 underscore handle. Okay, there you go. Fine. So now let us try to model this knob, which is the 6th component. Let us see how to do that. Okay, so to do this, we'll go to the front plane. Okay, and draw a line like this. We need to draw a sphere first. That sphere needs to have a diameter of 14 mm. I'll select the center and say this is going to be the midpoint. Origin is going to be the midpoint. The diameter is going to be 14 mm. Okay, like this. Yes, and with the center as the origin, I'm going to draw a circle, and basically I'm going to trim this side. So I've got a what do you call this, half circle here. Okay, and now I'll go to features and revolved boss base. Select this one here. So this is how we create a sphere. Okay, a sphere is now made, and now let us try to draw this cut here, 6 mm diameter cut, which is 7 mm deep. Okay, to do that, you'll go to, we need to create a reference plane. That reference plane has to be with respect to right plane. So select right plane, go to reference and say plane, and so the distance is going to be half of the diameter, which is going to be 7 mm, and then say flip offset. Yeah, so when you say 7 mm, it's going to touch the circumference of the circle. It's just tangential to the circle. So select this plane and go to sketch. Okay, alright, so now with the center as the origin, draw a circle of diameter 6 mm. Okay, diameter is going to be M6, right, as you can see here, M6, 6 mm, and now use the cut command. Go to features, extruded cut, and draw it to a depth of 7 mm as it is shown here. Alright, so this looks cool, and so now you can see that the hole has been made. Let us draw the chamfer and chamfer this part to 1 mm. Yeah, because it is given here M6 1. Yeah, that's it. So the knob is also ready. I'll hide this. So as I told you, except part 2, all the other components are pretty easy. Yeah, I'm going to save this part as part 6 knob. There you go. So now we are going to create the last component, which is the spring pin that you can see here. The spring pin, this is the last component that we are going to model now. To do that, we are going to go to File, New Part, okay, and then MMGS. This is a very easy thing to draw. It just needs to be a steel pin, okay, of diameter 8 and extruded to a depth of 18 mm. So go to front plane. It's a very simple extrusion, just a mere extrusion. So draw a circle of diameter 8 mm like this, 8 mm, and extrude it to a depth of 18 mm. Extruded boss base, that needs to be 18 mm with the mid-plane option on. Alright. It's nice if you can change the color to this, okay, because then you will not be able to differentiate it when it goes into this yoke. So when you're doing this, in this entire drawing, the material for each of the component has been specified. So again, I'm giving you a gentle reminder, do change the material as specified, okay. So this is going to be yellow, maybe this color, I can even say red pin, okay, some color. So I'm going to save. File, save as part 7 spring pin, okay, spring pin. Perfect. So now we have completed modeling all the components. It's time for us to assemble them together, okay. So go to File, New, and select Assembly. So let us begin by placing the yoke. So we'll go to Insert Components. Because I haven't closed any of the components, it is right away available here, or you can even go to Browse and select Part 1 yoke, okay, and just place it here. So it is always important that the centroid of the part should coincide with the centroid of the origin assembly. So to do that, make sure that you right click on the part and say float first, okay. Basically it will be fixed. This icon here indicates whether the component is fixed or whether it is floating. If it is fixed, the alphabet F will be indicated, and if it is floating, this negative will be indicated as it is, as my mouse pointer is on right now. So now you go to visibility here, okay, and select all these options on view origin, viewpoints, and view origins. So now the two origins, as you can see, are away from each other. So select these two origins by pressing and holding the control key, and then go to mate. Okay, so now you can see that the centroid of our assembly and the centroid of the body are going to coincide. Alright, so once this is done, right click on part 1 again and go to fix. Not fix, or you can even make float, both are same. Earlier it was float and now it is fixed. Yeah, so make it fixed. Now you can see that from negative it has now become F, which means it is fixed. Okay, perfect. So now let us insert the second component. I pretty well know how the assembly is going to look like, so let me just go to the full screen mode. Yeah, so now let us place the two fingers here. So go to insert components and bring in part 2. Okay, it's going to be the arm, and just place it here. And now if you can see, this arm has to come in here, right? So you can go to mate, and this distance, if you remember, I'll just go back to the drawing. This distance here is 6 mm, as you can see here, but this thickness is only 5 mm, right? So this face is not going to touch here, right? But it has to be equidistant. To do that, you have to go to advanced mates and go to width option. Okay, so you'll have to do two selections. Okay, sorry, before that what we need to do is, like, we have to turn this on, view axis, okay, view temporary axis, turn both of them on, and this center, this hole should coincide with this hole. Only then the spring pin will be able to sit in pretty easier. So go to mate, and then select this origin here, not origin, sorry, this axis here, okay, and then this axis here. Okay, the moment you do that, now if you can see, the centers are going to be in one line, yeah, so that it is easy for us to mate. Alright, now let's go to the next mate and use the advanced mate option. In that, we have to make two selections. One is the select width one, and then width selection and tab selection. In width selection, select this face here and this face here. Okay. In tab selection, select this inner face of the yoke and this inner face of the yoke. See what happens? Perfect. So now our arm has been perfectly placed, equidistant to this hole. So what you have done now is, like, if I'm going to zoom in here, now you can see that this thickness is 6 mm, the gap, but the thickness of the arm is only 5 mm, right? So it is equidistant from both these ends. Perfect. So this looks good. Now we need to have the same arm on the other side, so you don't need to do the assembly again. So you can go to mirror components, and the mirrored plane is going to be the right plane, yeah, and the components to mirror are going to be this arm, yeah, and then click OK. Now you can see that on both sides the arm is ready, and now what we are going to do is we are going to place the what was that component called? I forgot the name. Part 4, I guess. Yeah. Now what we are going to do is we are going to place the spread net. Okay. So go to insert components, bring in part 4, and place it here. And now this axis and this axis has to be coincident. So go to mate. Yeah. So this is touching here. It should not be like that. So right click. So come out of mate. Right click this component and you can say move with triads. So now you can move it along XYZ. Okay. Now select this face of the spread nut and this part of the arm and say mate component. Okay, it's not working. Why is it not working? Let us find out. I think it can happen on this side maybe. Select these two and say mate. I think it should work. Yeah. Something is wrong. Let's find out what it is. Like, go to mate, and or what we can do is, like, instead of doing this, we can check what the distance is from the drawing. Okay. Yeah, I think we can do that. From the center of the nut, I think this center has to be, let's just calculate that. So if you see in this drawing, from this center to this top, it is 29 mm, right? So that is where the top plane of the spread net should also be. So we'll go to mate, and let us open this tree here, and in the spread nut we have got the top plane, and in the yoke also we have got the top plane. Select those two and go to distance. Oh my god, my distance is in inches. I forgot to change that, so I'll change it to mmgs, and let me repeat it. Go to mate, select the top plane of the yoke and the top plane of the spread nut, and define a distance there. The distance has to be 29 mm. Perfect. So now you can see that the spread nut is touching it. Oh, it's not touching it. What happened? I think something is wrong with the distance that we are given. Let us just check the mate. Yeah, edit feature 29, or probably you can just make it 30, 28 maybe. Let us just check it up. Yeah, I think it should be fine now. Or you can make it even lesser. So this is slightly tricky. We need to find out where it is exactly. Yeah. So let me just decrease it a little bit. Call it 27. Let me just check. Yeah, I think this should be fine. Yeah, now it is touching it, as you can see here. Perfect. So this looks pretty good. And now let us bring in the screw. So you can bring in the screw and drop it here, and then you can go to mate, select this one here and this axis here. Okay, and now the distance can be anything. Okay, so I'm just going to move it with triads, and I'm just going to pull it up like this, because that is what is the functionality, right? So this puller is free to move up and down, and as it moves up and down, it will move the finger. That's how it works. Let's insert the next component, which is going to be the arm. No, not the arm, sorry, handle. And the handle, let us place it like this, and select this axis and the axis of this circle. So if we can zoom it here, there is one axis here, right, inside. Select this one and select this axis. Okay, and go to mate. So they are going to be concentric. Now the right plane of the assembly and the right plane of this component that we brought in now, okay, has to be coincident. Let's see how to do it. So what we can do is we can select the right plane of the assembly and the origin of the handle and say okay. So now it is coincident. Okay, alright. So now we are coming towards a close of the lecture. So we'll bring in the last component, which is going to be the knob. So we'll go to part 6, which is, okay, we have one more component, sorry, which was the spring pin. I forgot that. We'll do that later. Alright, so this is the knob, and we have to create a mate. So let me zoom in, go to mate, and select this axis here, and then the axis of the handle, like this. Okay, alright, now select this face here. Let me zoom in, select this face of the handle, and then zoom into the knob, and you'll find the inner face, okay, inside the knob. Select this face. There you go. So now the knob is properly placed. You can even mirror this. So go to linear component pattern, go to mirror pattern, and then mirror plane is going to be the right plane, and components to mirror are going to be this knob. Select this and then say OK. Perfect. So the last component that we need to insert is going to be the pin. You go to insert components, and then this pin. Okay, spring pin. Perfect. So select this axis and this axis, and say mate. Okay, so select this axis and this axis, and you can go to mate. Okay, it has not been selected, or you can even select this circumference. Okay, both are going to be same. both will do the same thing, and select this face here, okay, and this face here, and it is fitted. Perfect. So now we can mirror it. So you can go to mirror components, and mirror plane is going to be the right plane as usual, and then components to mirror is going to be this component. Perfect. Everything is done. So the assembly looks great to me. Uncheck all these things here, okay, so that the assembly looks perfect. And this is how the two-finger gear puller, is modeled using SolidWorks. So that's the end of the lecture, and thanks for watching the video.